This video is the next video in the functions videos, and in particular this video is looking at graphing quadratic functions. So remember that quadratic functions, or even quadratic expressions, they are expressions or functions that have squared numbers within them. And when we graph those type of functions, they form U and N-shaped curves. So on the page in front of you here, you can see that I have a few examples of different quadratic functions, and if you look at them all, you can see that they all have squared numbers. So in the first one we have just x squared, the second one x squared, there's 2x squared in the third, the fourth one has x squared, and the last one has a quarter x squared. You can see then that each of the functions here, they all have x squared in it. It doesn't really matter what number is in front of that x squared, it just has the x squared. The next question people always ask is, how do you know whether it's going to be a U or an N-shaped graph? Well, to answer that question, a U-shaped graph will always be a positive, so there will be a positive number in front of the x squared, and an N-shaped graph will always have a negative number in front of the x squared. And as you can see, I've just written it down below. So how do we know if it's a U-shaped or an N-shaped graph? If x squared is positive, we get a U-shaped. If x squared is negative, we get an N-shaped. This video is going to look at just drawing quadratic functions. We're not really going to focus on the properties of quadratic functions, like what happens when it crosses the x or y axis, how do we find that out, and so on and so forth. We're just looking at graphing quadratic functions in this video. The next video after this is going to be looking at the properties of quadratic functions. So if you have a few questions about that, don't get too worried about it at the moment. This video is just all about graphing the quadratic function. I have an example included on this just so you can see a typed out version. It might be a little bit easier to read than perhaps maybe what I'm going to draw on the whiteboard now in a few minutes. This example though says let f be the function f dot x goes to 2x squared plus 140x. It says evaluate f of x when x is 0, 10, 20, 30, 40, 50, 60, 70. And hence draw a graph of the function for f for x between 0 and 70, where x is an element of OR. Remembering that OR stands for a real number, and a real number is just any number. So the solution then is included here. It says make a table when evaluating functions with numerous values, and we're going to be doing that for every time we draw a quadratic function. We make a small table to make our lives much easier so we can get the point that we need to plot. Underneath that then it says on a graph f dot x goes towards, or f of x, both stand for y. So that's really important. So we have on the left hand side over here we have our x, and on the right hand side we have our y, so we're able to form our points then after that. So the first thing we do is it told us it wanted us to plot it between 0 and 70, so that's what we do. We write in 0 down towards 70 on the right hand side. Then on the middle one, what we do is we just fill in the quadratic formula. It's really important to have that written down so you don't make any mistakes. And then on the right hand side, we get the different answers that we need. The final thing you do then, part II, says hence draw a graph for f between 0 and 70. And that's exactly what we did here. So we have 0 starts here, 70 starts here, plotted the points and drew the graph. So the best way to learn how to do this is just to do a few examples. So question 5.1 says, let g be the function g dot x goes towards 7x minus x squared. It asks us to draw a graph for g where x is between 0 and 7. And again, we can see here that x is an element of OR, which is the real numbers, which of course is any number. So the first thing you're going to do is you're going to make a table. Now, we know that x goes on the left, so x is over here. The next column then after that is going to be the function, so we get y is equal to 7x minus x squared. We're okay with that because we know g dot x goes towards, or if we had g of x, that they both stand for y. So we've just replaced g dot x with y. Then the last column we need to have is we need to have our y column. So what answer do we get out at the end? Now it's asked us here to draw the graph between 0 and 7. We have 0, 1, 2, 3, 4, 5, 6, 7. Now this doesn't need to be any particular type of artwork that needs to be going on here. It just needs to be legible. So then we just fill this in. Doing this is really important because it means that you're not going to make any mistakes, and if you do make a mistake, the examiner knows exactly what your thinking was and can see exactly where you were going with the question. It does take a little bit of time, but you're rewarded for it in a minute when you're going to draw the graph, because it makes it much easier. A lot of people who try to do this question without drawing out this and without getting the point find it very, very difficult. So when we type these in, so for x is 0, you get an answer for y of 0. When it's 1, you get an answer of 6. When it's 2, you get an answer of 10. 3, you get 12. 4, you get 12. 5, you get 10. 6, you get 6. And 7, you get 0. So now we know the points. If you want, you could add another column in and you can just write the points to make your life easier. For example, the point we have here is 0, 0. We have the point 1, 6. 2, 10. 3, 12. 4, 12. 5, 10. 6, 6. And 7, 0. Now, the next thing we need to do is draw this graph. So I'm going to draw it here on the right hand side. So this will be our y-axis. And then I'm going to draw the x-axis along here. Now, of course, you'll be drawing this on in your maths copy or on an exam paper. There would be plenty of space, and all the graph paper would be lined out as well, so it would be much easier to draw. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13. And here we have 1, 3, 4, 5, 6, 7. You can see from the points that there's actually no minus figures, which is why I've mostly just drawn the top right quadrant, so quadrant number 1. So then all we have to do is plot the points. I would advise you to plot the points in a maybe red pen or green pen, so it's much easier. That's perfectly fine. The rest you should definitely do in pencil, but plotting it in a different pen colour was great, so that at least then you can see where the points are on the page. So the first point we have is 0, 0. Then we have 1, 6. Now, of course, my graph won't be as neat and tidy as yours, just because I've done all of this by eye. You will have your graph paper beside you when you're doing it. It's 3, 12, 4, 12, 5, 10, 6, 6, 7, 0. I'm going to draw it in blue. Again, yours is going to be drawn much nicer than this. However, my points are not as spaced out properly or in the right places as perhaps they should be. But you should get a graph something very similar to that. And that's this question done. You're just drawing the quadratic graph. Question 5.2 is very similar to question 5.1, and once you've done a few of these questions you should be able to draw quadratic functions no problem at all. But this one here says let f be the function f dot x goes to 5x minus 4 and g be the function g dot x goes to 3x squared plus 1. Part I says draw the graph of f dot x and the graph of g dot x for x between minus 2 and 2, where x is an element of or. Again, making sure you're aware that or is our real numbers, and real numbers stand for all numbers. So for the first part, we need to draw the graph of f dot x and g dot x. So I'm going to start with f dot x. Now we know that f dot x, or if we had f of x, that stands for y, and the very same with g dot x, or if we had g of x, that would stand for y too. So I'm going to rewrite f dot x goes to as y is equal to 5x minus 4. Now this is recapping drawing linear functions, and when we're drawing linear functions, the best and easiest thing to do is figure out where it crosses the x and y axis. So first of all, when it crosses the x-axis, y is equal to 0. So when y is equal to 0 here, we can plus 4 to both sides. 4 is equal to 5x, divide both sides by 5, and we'll get x is equal to 4 over 5. So the point then, I'm just going to write in blue, we have is 4 over 5, 0. And then the next one we have is when it crosses the y-axis. And when it crosses the y-axis, x is equal to 0. So we'll get y is equal to 5 times 0 minus 4. So y will equal minus 4. Then the point we have for this is 0 minus 4. So what we've done, just to recap there, is we figured out where the graph crosses the x-axis, and when it crosses the x-axis, y is equal to 0. And we figured out where it crosses the y-axis, and when it crosses the y-axis, x is equal to 0. The next thing we need to do is we need to get the values or the coordinates of the g of x. So we know that g dot x would be y is equal to 3x squared plus 1. So again, we can just draw our table. Now it says again that it wants it from minus 2 to 2, so minus 2, minus 1, 0, 1, 2. So this will become y is equal to 3 times minus 2 squared plus 1. Y is equal to 3 times minus 1 squared plus 1. Y is equal to 3 times 0 squared plus 1. Y is equal to 3 times 1 squared plus 1. Y is equal to 3 times 2 squared plus 1. So when we put minus 2 in, we're going to get an answer of 13. When we plot minus 1 in, we're going to get an answer of 4. When we put 0 in, we're going to get an answer of 1. When we put 1 in, we're going to get an answer of 4. And when we put 2 in, we're going to get an answer of 13. So the points then we have are, I'm going to draw them in blue, minus 2, 13, minus 1, 4, 0, 1, 1, 4, and 2, 13. So I'm going to draw a graph here now, and I think I'm going to draw it here. Now, so that's our x and y axis. I'm going to plot the line first, so I might actually do it in the points in red. So the first one we have is 0, minus 4, so the first point will be down here. And the second point we have is 4 over 5, which is 0.80, so that's going to be approximately there. Now, the next thing we have to do then is join those 2 points together. I'm going to do this in green, just so that we can tell the difference between the two graphs when I graph them. So that's going to go approximately up here. Now, again, yours is going to be much better because it's going to be on graph paper. It's going to be much easier to draw, but that's kind of the gist of it. You're also going to draw with a ruler because it's a linear function. Now, the next one I'm going to plot in blue maybe. So we have the point minus 2, 13. So that's going to actually be right in the center of this point here. The next point after that we have is minus 1, 4, so it's going to be here. Then we have 0, 1, it's going to be here. 1, 4, which is going to be here. And then 2, 13, which is going to be up here. Again, we have to draw this. I might draw it in yellow. So as I've said loads of times before, yours one will be much better than this, because you will be using graph paper, be nice and clear, but it should get something similar to that. Now, that's the two graphs drawn there. Then the second part says, where do the graphs f.x and g.x intersect between -2 and 2, where x is an element of OR? Now, a lot of people will get really, really confused, really worried, and start getting really stressed about this, and they would think that they have drawn the graphs wrong. But if you look at the graphs here, they don't intersect at any point. So that's all you have to say. So they do not intersect between x where it's -2 and x where it is 2. And that's this question done. And that's this video done. So this should hopefully explain how you would draw quadratic functions. It gives you two solid examples of what you should do every time you're asked to draw a quadratic function. It won't get any more complicated than this when you're drawing quadratic functions. It's literally just drawing out your table, putting in your x values, subbing it into the formula, getting out your y values, plotting it on the graph. It might take a bit of time to getting used to. It might take a bit of time becoming comfortable with drawing the actual graph, but other than that, it's not going to change at all. So the next video will go through the properties of quadratic functions, but that's the end of this video.